Hey everyone! Welcome to today's video. We're diving into the fascinating world of neural networks. Whether you're just starting out or looking to learn more, I've got you covered. Neural networks are a game changer in AI, and understanding them is key to unlocking their potential. Types of neural networks. All right, let's talk about the different types of neural networks. 1. Artificial neural networks. So first up, we have artificial neural networks, or ANN for short. These are like the jack-of-all-trades in the neural network world. Pattern recognition. Ever wonder how your phone can recognize your handwriting? That's pattern recognition. ANN can spot patterns in data and make sense of them. Classification. Then we have classification. Imagine how your email knows which emails are spam and which aren't. Yep, that's ANN at work. Regression tasks. And for things like predicting house prices based on various factors, ANN can handle those too. Super handy, right? 2. Convolutional neural networks. Next, we have convolutional neural networks, or CNN. These guys are like the vision experts. Image recognition. CNNs can look at a photo and identify objects in it. Think about your phone's camera recognizing faces, or even your pet. Video processing. They're also great at analyzing video frames. Perfect for things like security cameras or sports analytics. Object detection. And they don't just see objects, they can tell you what and where they are in an image. That's crucial for self-driving cars. 3. Recurrent Neural Networks, RNN. Moving on, we have Recurrent Neural Networks, or RNN. These networks are memory champs. Natural language processing, NLP, RNNs can handle tasks like translating languages or generating text. Think of chatbots that can chat with you almost like a real person. Time series prediction. They're also great for predicting future trends based on past data, like stock prices or weather forecasts. Speech recognition. And, of course, converting your speech into text. That's how Siri and Alexa understand you. 4. Generative Adversarial Networks. Finally, let's talk about Generative Adversarial Networks, or GAN. These are the creative artists in the neural network family. Image generation. GANs can create super realistic images from scratch, used in everything from video games to digital art. Style transfer. Ever wanted to turn your photos into paintings? GANs can do that by applying artistic styles. Data augmentation. They're also great at generating extra data to help improve model performance, especially when data is hard to come by. Structure and function of neural networks. Now let's break down how these neural networks are structured and what they do. 1. Artificial neural networks. Structure. ANN has a simple and straightforward structure. Think of it like layers of an onion. Input layer. This is where all the data enters. Imagine it as the senses of the network, taking in everything. Hidden layers. These are like the brain cells, processing and transforming the data into something useful. Output layer. This is where the network gives its final prediction. It's like the mouth of the network speaking the result. Function. Forward propagation. The data moves through the layers, getting processed at each step. One versus all training. Each output neuron learns to recognize one specific class. Prediction. The neuron with the highest activation is the network's best guess. 2. Convolutional Neural Networks, CNN. Structure. CNNs have a more complex structure, perfect for handling images and videos. Convolutional layers. These layers are like the eyes, detecting features such as edges and textures. Pooling layers. Think of these as a way to zoom out, reducing the size but keeping important details. Fully connected layers. These layers make sense of all the features and give the final output. Function. Feature detection. The network identifies important features in the data. Dimensionality reduction. It simplifies the data, keeping only the crucial parts. Classification. The network uses the features to classify the input. 3. Recurrent Neural Networks, RNN. Structure. RNNs are built to handle sequences and remember past data. Recurrent layers. These layers have loops, allowing the network to remember previous inputs. LSTM GRU units. These special units help the network maintain long-term memory. Function. Sequence processing. Perfect for tasks where the order of data matters. Temporal dependencies. The network updates its state at each step, remembering the context. Backpropagation through time. a training method that adjusts weights over time. 4. Generative Adversarial Networks. Structure. GANs are unique because they have two parts, the generator and the discriminator. Generator. Think of this as the creative artist generating new data from scratch. Discriminator. This is the critic evaluating the data to determine if it's real or fake. Adversarial training. Both parts improve by competing against each other. Function. Data generation. The generator creates fake samples evaluated by the discriminator. Adversarial learning. The discriminator helps the generator improve. Minimax game. The generator tries to fool the discriminator, and the discriminator tries to catch it. Conclusion, and that's a wrap. Today, we explored the various types of neural networks, their structures, functions, real-world applications, and future directions. Neural networks are a fascinating and ever-evolving field. If you enjoyed this video or have any questions, drop a comment below. Don't forget to like, share, and subscribe for more awesome content on neural networks and AI. See you in the next video.